All right, let's go ahead and get started with our Tutor Tuesday then. My name is Dan from Dan's Test Prep. I do these every week, and basically we're going to go over some SAT math, ACT math, and then some AMC math problems. While you're here, you can check out my Explore page, explore.danstestprep.com. I have all my social media on there, more helpful resources, and my weekly SAT newsletter, which, by the way, if you refer some friends to that, you can get some of my free resources and even a free tutoring session with me. So yeah, like I said, we'll start with some warm-up SAT problems. For those of you who can't see it in the chat, let me paste it in. Yeah, you're welcome to stay. Um, Number 3 here says, in the figure, line M is parallel to line N and line T intersects both lines. And I see in the chat we've got corresponding angles, which is completely correct. Or in this case, it's going to be angles that are supplementary to each other. Looking right here at this 33-degree angle, if we shifted that over right here, that would fit perfectly. So this is two parallel lines cut by a transversal line. And that means that this exterior angle, x degrees, it should add up to 180 combined with a 33. So for those of you who are very quick solvers, I see you've already got the answer, which is that x has to equal to 180 minus 33, or 147. That's going to be D. Yeah, this is this is the SAT. This is the third problem in the section, so it's kind of just one of our warm-up problems. You guys are welcome to stick around for some of the harder problems later on. 13, so here's our next warm-up problem. F of x is equal to 4x squared minus 50x plus 126. The given equation defines the function f for what value of x does f of x reach its minimum. So the minimum value, I know that when the parabola opens up, or the quadratic opens up, the minimum value is going to be at the vertex. The value of x for which we find the vertex is just equal to negative b over 2a, which in this case is negative of negative 50 over 2 times 4. Right, so 50 over 16, that's equal to 25 over 8. That's about like 6.25. So this is the x value for which we get our minimum. Yeah, the SAT covers up to like Algebra 2 and pre-calc, and I would say this is more like an algebra or Algebra 2 problem. All right, next one, number 17. Paste it in for you guys. The circle shown has center O, circumference 144 pi, and diameters PR and QS. The length of arc PS is twice the length of arc PQ. This right here is twice the length of PQ. 2 times 1 times. What is the length of arc QR? That's what we're trying to find. Well, if I know that PQ is one measure, PS is 2 times that, and since these pass through the center of the circle, this is also 1 times, it's the same as PQ. This is, I could label as 2x. Basically, we split this up into parts, where the whole circumference is equal to, if I set this as just x, these side lengths are twice, or these arc lengths are twice x. We add everything together and we should get 6x equals 144 pi. All of these arc lengths should add up to the total circumference. So of course x is going to be equal to 24 pi. And if we're trying to find an arc length QR, remember we label this as the 2x side, twice the length of our base x. So 2x is going to be equal to 48 pi. That's going to be B. This is the digital SAT non-adaptive practice test number 2. Alright, what have we got for our last warm-up problem? Number 21. Remember doing this one? Yeah. Nice. Number 21 says, in the given system of equations, A is a positive constant. The system has exactly one distinct real solution. One distinct real solution. What is the value of A? So I see we've got a linear equation, y equals negative 1.5. Looks kind of like this. And we've got y equals x squared plus 8x plus a. Something like, oh, I don't know. If we wanted to have one solution, it's going to have to intersect at exactly one point. Yeah, you're right. We could find the vertex, and the y value of the vertex would have to equal to 1.5. That's an interesting way to approach it. I was actually going to use a discriminant. So let's do both methods here. If we want these two equations to be equal, let me do method 1 first. Method 1, discriminant. And then we'll do vertex. Maybe vertex is actually faster. I know that these two are equal. Y equals 1.5 and y equals x squared plus 8x plus a. It's not calculus, but is some algebra, or algebra 2. If these two are equal, though, I know I can replace y equals with each other. So negative 1.5 is the same thing as x squared plus 8x plus a. And that's true because we want this quadratic to be equal to the negative 1.5 line. Then we can rearrange this by adding 1.5 to both sides, setting this equal to 0. And for the discriminant, we want the discriminant equal to b squared minus 4ac. We want that equal to 0. Or in other words, 8 squared minus 4 times 1 times a plus 1.5. We want this discriminant exactly equal to 0 so that the system has one distinct solution. Vectors. Oh, we've got a vectors problem coming up for the ACT, so just stick around for that. It's a bit of a simple one, but it's good. When we evaluate this, we get 64 minus 4a minus 6 equals 0. We've got 58 minus 4a equals 0, or 4a equals 58. So when I simplify that out, 58 over 4 is going to be 14.5. I do hope that that one is correct. But even if it's not, we can cross-check with the second method. Method 2, which is the vertex method. Vertex is going to be given by negative b over 2a, which in this case is negative 8 over 2, which is at negative 4. That is the x value of the vertex. So the y is going to be equal to 4 squared plus 8 times 4 plus a, and we want that equal to negative 1.5. Negative 1.5 is equal to 16 plus 32 plus a. Or sorry, this should be 8 times negative 4. So 16 minus 32 plus a. So I can simplify this 16 minus 32. It's going to be negative 16. Negative 16 plus a. We add 16 to both sides, and we get 14.5 is equal to a. No matter which way we do it, we're going to get a equals to 14.5. For anybody who can't see the screen also, I post these in my YouTube channel afterwards, which you can find on this explore link right here, explore.dancetestprep.com. Let me put that in a chat. Okay, that was a good warm-up, I think, for the SAT. What I'd like to do next is, well, let's see in the chat. Do you guys want to do ACT next, or do you want to do some of the community SAT problems? Let's see in the chat. ACT or the community submitted problems? Either one? Okay. ACT. I see some people are here for ACT prep, so let's go do those next. And in the meantime, if you guys send me a picture of your problems, I will add them down here below, and we'll do those next after the ACT. ACT problem number 28. The solid rectangular prism shown below was built by alternating congruent black and white cubes such that two cubes of the same color have at most one edge touching. What is the total number of white cubes that were used to build the prism? I don't know, what do you guys think? Take a look. I think this one, if you know the trick, it's not too bad. You guys figured it out yet? Well, I noticed since they're alternating, right, we're going to have one white cube and one black cube, and they're going to keep alternating. It's actually going to be, if we look at this face, about half of them are black and half of them are white. One half black, one half white. Now, if we could just get the total volume, since these are, it looks like we can call these as unit cubes. They take up 1 unit of space. If we can find the total volume in units of this whole thing, we should be able to get our answer. It's not exactly a cube though, it's a rectangular prism. So the dimensions of the prism are 7 by 6 by, sorry, that's 5. 7 by 5 by 6. And I see we've got some calculations in the chat. The total volume is going to be 7 times 6 times 5, which is 210. Okay, so answer choice K, right? Wrong. We're asked to find the total number of white cubes that were used to build the prism. The number of white cubes is going to be the total volume divided by 2. 210 divided by 2 gives us 105 specifically white cubes that were used to build this prism. So that would be H. Whoever said H was correct. All right, this is that this is the vectors problem I was talking about. The vector I represents 1 mile per hour east. Actually, I wanna draw this out so it's more clear. I represents 1 mile per hour east. And vector J represents 1 mile per hour north. Maria is jogging south at 12 miles per hour. One of the following vectors represents Maria's velocity in miles per hour. Which one? Any ideas in the chat? Think it's A? Let's see. If we're going, yeah, if we're going south, then the vector component that's in the east and west direction, that's not going to contribute to Maria's velocity, right? We could actually rule out even, we don't even need to consider the east direction because she's moving purely south. South. So we need to consider vector j. Vector j. Yeah, 12j would equal 12 miles per hour north. If we negate that, we can get negative 12j and get 12 miles per hour south. So definitely it should lead us to answer choice B. And you see I never comes into the picture. We can eliminate anything that has to do with I because I strictly corresponds to the east and west direction. You can submit the questions to me in here in the chat or in DMs. Okay, I've got a couple more questions. I paste this one over here. That's going to be for later, after the ACT. And we got one more. That's going to go right here. These are some huge files. Oh, nice. Calculus. We'll do that one after. Yeah, send whatever problems you guys want. It has to be SAT or ACT. If it's not those, then I'm going to cover it after the session. Let's move into number 40 here, which I'll paste for you guys in the chat. Okay, nice. We got a good collection of problems here. I'll paste in the next SAT problem. Number 40, ACT problem. Regardless of how the graph is oriented in the standard XY coordinate plane, no graph in one of the following categories has a vertical line of symmetry. Which one? Oh no. What do you guys think? Everything here is symmetrical or has a vertical line of symmetry except for one. We can even do this by a case by case basis. A line, let's do line. Line has a vertical line of symmetry here. So we could rule out line. Square has a vertical line of symmetry down the middle. We could rule that out. Pentagon, you could orient a pentagon, or at least a regular pentagon, such that it has a, or even a non-regular pentagon, that has a vertical line of symmetry right there. Parallelogram. Parallelogram is hard, right? Usually you draw parallelograms like this, and in that case there's no vertical line of symmetry. But what if I rotated this and then I got this? This figure right here. Ooh, okay, that's tough. That's tough to draw. We want this point right here to coincide with this one, and this one. Then to the left of this point is going to be, oh man, it's very hard to visualize actually. But this point right here will correspond to this point right here and this point right here. And then it'll look something like, oh my, maybe like this. No, that still doesn't have a vertical line of symmetry. Let me skip for that one. Let me skip through that one and do a scalene triangle. Okay, who remembers what a scalene triangle means? Basically, all three side lengths in a scalene triangle have different lengths. So a scalene triangle could look something like this, that, and that. Yeah, all unequal sides. Basically, if I had a triangle that was all unequal, then it'd be impossible for us to get a vertical line of symmetry, because in order for that symmetry to exist, we would need equality on the left and the right hand sides. So we would need at least like an isosceles triangle versus something like a scalene triangle. There's never going to be any symmetry on both the left and the right, and hence there's never going to be a vertical line of symmetry. Equilateral could also work. But yeah, that is why for this question, the scalene triangle we definitely know is not orientable such that it has a vertical line of symmetry. Um, Parallelogram. Parallelogram is, just to go over that one real quick and show why it does have a vertical line of symmetry. Parallelogram, the definition of a parallelogram is just that it has a pair of opposite equal sides. So, depending on the type of parallelogram, I mean, like, you could have a parallelogram that doesn't look just like a general parallelogram. You could have a parallelogram that looks like a rhombus, diamond, or even a square. A square is a parallelogram. So that, in that case, you could have the vertical line of symmetry. It doesn't just have to look like what you think of when you think of parallelogram. And the last one, number 53, which I'll put in a chat right now. Given that f of x is equal to x squared minus 4 and g of x is equal to x plus 3, what are all the values of x for which f of g of x equals to 0? I hope you guys remember function composition. F of g of x is not too bad if we apply those rules. F of g of x, we have f of x, we have g of x. What this means is we take g of x and we stuff it into the input for f of x. F of x plus 3. Right, g of x is x plus 3, so f of x plus 3 is just equal to x squared, except our input is x plus 3 minus 4. F of x plus 3 is equal to x plus 3 squared minus 4. Expands out to x plus 3 squared minus 4. That's x squared plus 6x plus 9 minus 4. X squared plus 6x plus 5. When we set those equal to 0 like the question says, we can factor that as x plus 5, x plus 1. So yeah, x equals negative 5 and negative 1. Answer choice A, just like you solved in that chat. Composite functions can be pretty fun. Alright, so I know a number of you guys submitted some SAT problems, so let me go through some of those, and you can still submit some more for me to go through. It's good that you're prepping. I know the October SAT is coming up soon. This first one here says in the equation above, k is greater than 1 and x equals 3. What is the positive value of y? Oh, PSAT in October. Yeah, PSAT is going to be digital this October, so you better be prepared for that. I'm going to plug in the values that they gave us here. Right, k to the power of 3 squared plus 3y times k to the power of y squared plus 3y equals k to 25. Alright, what else can we do here? Since we've got the same base and we're multiplying two bases, we can add the exponents together. Right, k to the power of 3 squared plus y squared plus 3y plus 3y equals k to 25. So what's that mean? I see a form that is emerging here that might make this easier for us. And if I rewrite it as k to the y squared plus 6y plus 9, you guys may be able to see where I'm going with this. Since we've got k and k as both of our bases, we should be able to just equate the exponents. So, and also this factors as y plus 3 squared equals 25. Really nicely set up for us here. So if we square root that, what we'd get next is that y plus 3 is equal to plus or minus 5. And from there you get two solutions. Y equals negative 3 plus 5, or y equals negative 3 minus 5. And since they asked for the positive solution, I'm going to go with the answer of 2. That would be answer choice B. Yeah, I don't really know what to say about the National Merit Scholarship qualifying score. Since the PSAT and the digital PSAT are supposed to be similar in difficulty or the same, then it might stay around the same. Alright, whoever sent in this next question, ooh, this one is tough. Not like in difficulty once you know what to do, but you have to do a few steps to get it into the right format. The equation 24x squared plus 25x minus 47 over ax minus 2 is equal to negative 8x minus 3 minus 53 over ax minus 2. It's true for all values of x where x does not equal 2 over a. Oh my god. What is the value of a? Yes, I did take the PSAT back in high school. How do you think I got to college for free? Little known fact, or maybe well known fact, I try to post on my TikTok. For this question, let's see what we can do. Yeah, benefits of taking PSAT. You can get full rides at some scholarship, some colleges. They give you scholarships. Otherwise, depending on the college you go to, it does kind of nothing for you except for something to put on your resume. For this one, I'm going to try to get this side to match up with this side. Specifically, I could multiply everything here by, or I could multiply these terms at least by ax minus 2. I went to college at UT Dallas. Actually, I'm still going here for grad school. 24x squared plus 25x minus 47 over ax minus 2. That's equal to, well, negative 8x minus 3. I'm going to multiply that whole thing by ax minus 2 because I want that common denominator. Common denominator. So that's equal to negative 8ax squared minus 3ax plus 16x. Did I do that right? plus 6 minus 53. It should not be 16x, it should be 16. No, that's right, 16x. This is all over ax minus 2. And remember, this matches up with 24x squared plus 25x minus 47 over ax minus 2. Since the denominators here are equal, I don't really need to consider that. I can just set these two parts equal to each other. And what I notice is that 24x squared matches up in a power with negative 8ax squared. So if we match our powers of x, negative 25x should match up with negative 3ax plus 16x. And then the constants should also match up. They've got to. Negative 47 matches up with 6 minus 53. So 24 should equal to negative 8a. That should give us a equals negative 3. And that gives us answer choice B. Yeah, quick way to do this could be, since they divided everything by ax minus 2, 24 over a is equal to negative 8. Yeah, that would be the result of that division right here. Or I'd be able to 24x squared divided by ax. That would give us 24 over a is equal to negative 8x. Definitely works as a quick solution. I do like this thorough solution though. They're both good. Alright, we got one more, or maybe a couple more questions here. If x is greater than 0, oh wait, this is two questions? Okay, let's do it. If x is greater than 0, what is one possible solution to the equation above? Let's see. I'm going to expand this out here. We get x to the 5th minus 5x cubed is equal to negative 4x. Move everything onto one side to get x to the 5th minus 5x cubed plus 4x equals 0. Of course, if I factor out an x, then I get x to the 4th minus 5x squared plus 4 equals 0. And then I can factor this as x squared minus 4 times x squared minus 1 equals 0. So the possible solutions, well, I guess let's factor this one more step. X squared minus 4 is x plus 2 times x minus 2 using our difference of squares identity. X squared minus 1 is going to be x plus 1 times x minus 1. So the possible solutions here are going to be x equals 0, negative 2, 2, negative 1, and 1. But the only valid ones are going to be 2 and 1 because we have that condition that x is greater than 0. So either one of these solutions would work. And then the next one looks kind of not that fun because we're dealing with fractions. If 7/9 x minus 4/9 x equals 1/4 plus 5/12, what is the value of x? Oh, so this is just a common denominators problem. Right, 7/9 minus 4/9 x is just 3/9 x. And that's equal to 1/4 plus 5/12. Well, 1/4 is just 3/12. So let's simplify that even further. We've got 1/3 x is equal to 8/12, which 8/12, if we divide everything by 4, is just the same as 2/3. So if we multiply everything by 3, we get x equals 2. quite simply. Ooh, okay. Don't know if I have space for this last one to put into the grid. Let me put it right up here, actually. Someone submitted this one. What is the set of all solutions to the equation x plus 2 equals negative x? Okay, so they give us possible solutions. We can check them. Instead of trying to solve ourselves, we can actually check these solutions. If we plug in negative 1, we get square root of negative 1 plus 2 equals negative of negative 1. That gives us 1 equals 1, which is true. Negative 1 definitely works. If I plug in 2, then I get square root of 2 plus 2 equals negative 2. Or 2 equals negative 2. That does not work. The only one is going to be b that works for this one. Cool. That's all the SAT and ACT problems I have. What I've got next to end off the session is some AMC problems. Or actually, this is from an older test called the AHSME, the American High School Mathematics Competition, which is now known as the AMC 12. So these problems are from 1999, but still like pretty similar to what the AMC is now. This one says, or I guess I should paste it in for you guys, the marked price of a book was 30% less than the suggested retail price. Alice purchased a book for half the marked price at a 50th anniversary sale. What percentage of the suggested retail price did Alice pay? Let X be the retail price? Yeah, let's do that. Let me do R as the retail price, because I like naming my variables after what they relate to. And then I bet you're going to say the marked price is 30% less than the retail price, right? So 1 minus 0.30 of the retail price. The marked price is actually 70% of the retail price. Then the percentage that Alice paid half of the marked price, which is 0.5 times 0.7 R. So multiplying all that through, she paid only 35% of the suggested retail price, because she got a 30% discount and then half off of that. So right, that brings it down to 70 and then all the way down to 35%. Alright, next one looks fun. I like this one a lot. What is the sum of the digits of the decimal form of the product 2 to the 1999 times 5 to the 2001? I bet you guys could get this in the chat. What are we going to do here first? 2 to the 1999 times 5 to the 2001 power. What I would do is convert this one on the right. 2 to the 1999 times 5 to the 1999 times 5 squared. Right? We could do that. Nice. Now what's 2 to the 1999 times 5 to the 1999? I mean, they've got the same exponent, so can't we just do 2 times 5 to the 1999. And then what is this? This is just 10 to the 1999 power times 5 squared. So that's going to be 25 and then like a bunch of zeros. Because this is going to be some like 10 to the 1999 is this huge number. It's just going to keep on going forever. When we multiply by 5 squared, or 25, the 1 goes away and we're just left with the 25, or 2 and 5 as the leading digits. And then all the other digits are zeros. So the sum is 2 plus 5, which is 7. Shift the decimal point in the 5. I'm not sure, but this is the way I would do it. Yeah, I'm not so sure what they mean by decimal form either, but this is how I would do the problem to get that sum of 7. This one's interesting. I haven't seen a problem like this. What is the largest number of acute angles that a convex hexagon can have? Convex hexagon. Okay. What do you guys think in the chat? It's kind of tricky, huh? Like, what does that problem even mean? Is it not just 6? Well, it's got to be acute angles, right? Hexagon has 6 sides, 6 angles, but it's, it can't just be 6. In a hexagon, in a convex hexagon, that means all the sides are going to be pointed out. The sum of angles is going to be 720 degrees. So yeah, we could do like 720 divided by 6 and get 120 degrees, and each of these be 120 degrees. That's just one case, but that doesn't give us any acute angles. We could, so for it to be acute, we would need it to be less than 90 degrees. We could do a hexagon that looks kind of like 1, 2, 3, 4, 5, 6. I guess it could be something like this, right? Or let me do it like 1, 2, 3, 4, 5, and 6. You could see some of these are acute angles. Like this one is acute, that's obtuse, that's obtuse. That one looks slightly obtuse. Actually, it looks like this one's the only acute angle based on how I drew it. But that's one possibility, right? That could give us an acute angle. But we can start to rule this, we can start to work with this and rule this down. We know that if every angle was acute, it would have to be less than 90 degrees. And 6 times 90 is 540. So definitely we cannot have all acute angles. And even for my drawing, you can see that. Can't have 6. We know we could have at least 1 just from my drawing. But we can do better than that. Let's say we had this. So this is the case of all acute. That wouldn't work. Let's try narrowing it down. Let's try working from the top and seeing what we can accomplish. What if we had 5 acute angles? We could have 5 angles that are just 90 degrees, and one of them could be obtuse and give us 180 degrees. This would sum up to 630, right? We'd have sorry, 450 from here plus 180 is 630. That does not add up to 720, so this would not exist as a hexagon. We could try 4 acute angles, right? 4 times 90 plus 2 times 180. That would be 360 plus 360, which is 720. But of course, this is a limiting factor. This is right on the cusp, or right on the edge of being acute, but these are right angles. So that would look something like you have 4 sides of 90 degrees, plus you have 2 sides of 180 degrees. That literally is, it's actually just a square with 2 extra points. But if we expand this just slightly and do 3 acute angles, let's see what that would look like. You'd have this one curved just slightly in, this one slightly in, this one slightly in, and then the other 3 sides could be, let me draw it bigger. This curves just slightly in, this one curves just slightly in, this one curves just slightly in. So these are all acute. 1, 2, let me make this one acute as well. So this one would curve just a little bit in. Then we need the remaining 3 sides, so we could do like 1, 2, 3. None of those are acute. But those 3 that I marked are acute angles. So we could have at most 3 acute angles. 4 would not work, and anything like 2 or 1 would just be too little, because we're asked for the largest number. Yeah, nice. 80 is less than 90. 9 minus 6 is 3. That's how I got 3. It kind of works. We got... Yeah, if you send a problem, can you send a photo just so I can paste it in? Oh, DM. Okay. I got some message requests. Yeah. We'll do that before the end of the session. Last AMC, or I guess AHSME problem. We're going to do this one right here. Let me put it in a chat. Okay. At the end of 1994, Walter was half as old as his grandmother. The sum of the years in which they were born is 3838. How old will Walter be at the end of 1999? Okay, so in 1994, Walter was half as old as his grandmother. Assign variables. Yeah, let's do maybe like Walter's age is... I like to use variables that are named after the people. So Walter's age is W, and grandma's age, it could be G. And I think it would be that Walter's age is 0.5 of grandma's age. Walter's age is exactly equal to half of his grandma's age. It's the other way around of what you wrote. But let's see, does that help us get our answer? I would say that could work. Yeah, that could help us. Or yeah, we could say that 2W is equal to G, right? If we want to find the years that they were born, or the sum of, so this is the next piece of information I'm going to use. The sum of the years in which they were born is 3838. Something plus something is equal to 3838. What I know is that the year in which Walter was born is just going to be the current year minus his age. And then the year in which his grandma was born is the current year, 1994, minus her age. Of course, we have this relationship 2w is equal to g, so we could do like 1994 minus w plus 1994 minus 2w. We just substituted that definition in. Right, so 1994 times 2, what's that going to be? It's going to be 4,000 minus 12, which is 3,988 minus 3 times Walter's age is 3838. All right, what have we got now? We could add 3w to both sides, subtract 3838. We would get a result of 150 is equal to 3 times Walter's age. And that would imply that Walter's age is equal to 50. But is that what the question is asking? How old will Walter be at the end of 1999? Very close, very close. Since 1999 is 5 years away, it would just be in 1999 is just Walter's age plus 5. He's 55. Did I get that right? Let me check. Yeah, should be 55. All right. Zoom out. Oh, I'm gonna post the PDFs for this afterwards. You can check my Explore page right here, and that's gonna have my YouTube channel, my website, and I've got the PDFs all posted on YouTube and my blog. Fun problem, yeah. Let me do a couple more problems. We've got actually a lot of problems this session. The next one that I was sent, I'm gonna do this one. We'll do just a couple more. 75i to the 29th. Alright, what I always do with I is just divide by 4 and take the remainder. This is 75i to the 28 plus 1. So I to 29th divided by 4 is equal to, or let me do it this way. 29 over 4 gives us a remainder equal to 1. So I to the 29th is basically equivalent to I to the first power. So yes, whoever says 75i, that's correct. I need to expand this grid, I guess. It's time for just a few more. Looks like some nice algebra problems. Next, we're asked to factor 25x squared plus 144. Alright, you guys must be really enjoying these bonus problems. Difference of sums. Let me see. What I would do is factor out. I see these are perfect squares actually. So what I would really do is I would factorize this as a perfect square. 5x plus 12 squared. And oh wait, that wouldn't work because you'd get some terms in the middle that we would have to take out. So I guess what you could do is just factor these separately, right? We could do 5x squared plus 12 squared. I'm not sure if you can get it any simpler than that. Yeah, that's what I would do. And what else? Someone else sent me another problem, and I think we've got time for one more. So let me just paste that last one in here. And let me paste it in a chat as well. Oh, okay, you're saying this one has to be factored with I. Yeah, I guess you could. If you're looking to factor with complex numbers or imaginary numbers, what you could do is, I know that this perfect square is 5x. This square rooted is 12. But of course, when we do 5x plus 12 squared, we're going to get 25x squared, and we're going to get some middle terms. That's going to give us 120x plus 144. So what I would do if I want to get rid of that is probably 5x plus 12i and 5x minus 12i, because this is essentially, if we rewrite this, this is 25x squared minus negative 144. That means what we have here is our perfect square in the form a squared minus b squared. Using the difference of squares formula, a is equal to 5x. Of course, b is going to be equal to 12i when we take the square root of negative 144. So it becomes a plus b times a minus b. So this should be your final factored form. And you multiply that out, you get back to the original equation without the middle terms. Yep. Last one here. Last one. We'll do this one. 3/4 sector of a circle of radius 12, immediately labeling that inches together with its interior can be rolled up to form a lateral surface of a right circular cone by taping together along the two radii shown. Dang, okay. What is the volume of the cone in cubic inches? Solid geometry, definitely. Rolling it up and taping together the two radii would form a cone. Lateral surface of a right circular cone. Yeah, I'm trying to visualize how this would look. You'd roll it up. The paper would kind of look like that. You roll it up and you want to combine these two together. So, rolled up. 3/4 sector of a circle. Okay. What I can tell here is that when we combine and we merge these radii together, what's going to happen? really got to visualize this here. Someone says E. It's a perfect answer. Alright, I think I can visualize this. When we combine these two sides, here's what's going to happen. This original side and this original side, they're going to merge, of course. We're looking at it kind of from not a 2D perspective, but kind of trying to draw it out 3D. Then the cone is going to look like this, and it's going to raise up into this point right here. It's going to be raised even. So if you look at it from the side, here's what the side view is going to look like. It'll look as if the cone kind of raised up a little bit as you folded it over. And from the top view, top-ish view, it's going to look something like this. Which means that this part in green will become the new circumference of your base. And the former radius right here, is going to become your slant height of the cone. That's your new circumference. Hopefully the visualization helps. And then this blue line is your new slant height of the cone. You guys following? Yeah, like an ice cream cone. So from there, the circumference of the circle, the original circumference, or the new circumference, I guess, is equal, circumference is usually equal to pi times, or 2 pi r. In this case, it's 3/4 times 2 pi r, since we only had that much of the original circumference. So 3/4 times 2 times pi times 12. So the circumference was equal to 3/4 times 24 pi, which is 18 pi. 18 pi. That is equal to the circumference of the cone. It's equal to the former circumference of or I guess this green circumference here. That is the full circumference of the new cone. So if we apply that formula again, 2 pi r, this time with the full base of the cone, 18 pi equals 2 pi r. That implies that our radius is equal to 9. So yeah, that makes sense, right? We had a radius of 12 before for this 3/4 circle. When we put it into a cone, the radius became 9. And all we need now is to calculate the height of the cone, which we can get using Pythagorean theorem. Height is equal to the slant height, which we said was what, 12? 12 squared minus the radius, which is 9 squared. Right, then we get that 12 there. We get that circumference, that gives us radius at 9 here. And then 144 minus 36 gives us h squared is equal to 144 minus is 108. h is equal to the square root of 108, which in other words is, let me move it over here. Square root of 108 can be written as, it can be simplified at least to 2 times 54, or 2 times 2 times 27. That's 2 times 2 times 3 times 3 times 3. So the height becomes, if we pull out these, 2 times 3 times square root of 3, or 6 root 3. Finally, volume. Volume is 1/3. I'm pretty sure volume of a cone is 1/3 pi r squared h. 1/3 pi, radius was what, 9 squared, and height was 6 root 3. So we get 1/3, or I guess 1/3 times 9 squared, where 9 squared is 81. If we take 81 divided by 3, we can get 27 pi times 6 root 3. And then what's 27 times 6? That's going to be 162 pi root 3. Don't think that matches with any of the answer choices here, which is interesting. So maybe we made like a small math mistake somewhere. You guys see any errors here? Let's check circumference with 3/4 times 2 pi r. 3/4 times 24 pi. Typo for the prep. Okay, we'll just chalk it up to that. I would guess that maybe this choice is supposed to match up with this one, right? 27 pi times 6 root 3 instead of root 63. So I would guess B. Yeah, maybe just like an error in the typing of the question. Cool. That was a tough one. Let's end off the session there, guys. Thank you very much for joining. Don't forget, explore.advancedtestprep.com. This will be on YouTube as well. And on my blog, I have all the PDFs. You can also sign up for a weekly SAT tip on my newsletter. And yeah, I'll see you guys next week. Bye-bye.